sort of difficult to figure out which day it is and which day of the week it is. All right, so where are we? Uh, Before I start, are there any questions? Now, if you're worried about not sort of being idle in this course, I have a bunch of work for you, and you'll get that a couple of different pieces of work. So I'm not going to do sort of like in-class quizzes anymore. I'll give them, and you can do them at home. And then I'll also give you an assignment. Okay, so I also want to give everybody a sense of what we're going to do. So today I'm going to finish up a bunch of stuff that sometimes people don't think about and is fairly low level. When I say low level, we're not dealing with bits, but instead, you know, I'm talking about variadic functions. Now, if you've never heard the term, you'll hear that today. And there's a lot of, I was just checking a web page the other day, and C is the #1 language at the moment, right? C++ is 3 or 4. In between we have Python and Java. But a lot of work that is done in Python is C related and sort of C++ related. And I'm not entirely sure if you can actually program in C++ without worrying about stuff that is done in C, especially if you're writing bindings that interact with things like, that are more or less always C oriented, like OpenGL, maybe, or Python. You want to take some C++ stuff and connect it to C. So I thought today we'll talk a little bit about how to combine code from C and C++ into a single program. And if there is a little bit of time, then I want to quickly run through the idea of uniform initialization, because I haven't kind of done it formally, because C++ is sort of quite a mess in terms of initialization. Then on Thursday, I would like to talk about smart pointers and hopefully get you guys to move away from raw pointers. And then we'll not just talk about the standard library raw pointers, or excuse me, smart pointers, but we'll also look at how to design one and implement one. And the reason for that is if you're working in an embedded environment, maybe you can get your entire C++ sort of library. You have C, C++, and you kind of need to know how to build your own smart pointer. So we'll look at that. And then if time permits, I'll talk to you guys about RAII, which really is a oxymoronically named thing by Bjorn Strustrup. Resource acquisition is initialization, and it's all about how to design classes. So we'll look at that. And then I want to talk to you guys about what is called return value optimization. And then we have something called named return value optimization. There used to be the traditional rule of 3. So I'm going to speak to you guys about a new type of reference called R-value references. So the references that we have been using in C++ really are used to be called just references, but since 2011, they have been renamed to be L-value references because we have a new type of reference. Some people call it universal reference, but more clearly it's called R-value reference in the standard. And then we'll talk about Mu semantics and what that means, what is the purpose of that, and then how, when we talk about class design, we move from rule of 3 to rule of 5. And then I'm going to talk to you guys about rule of 0. So in the future, how to design classes so that you end up with a sort of simplest possible way to implement classes using the ideas that we have discussed earlier, which is smart pointers, RAII, and move semantics, and which essentially leads to something called rule of zero. Now, after that, I just kind of also want to give you sort of, if you're interested, what we are going to do after that. After that, I'm going to spend an entire week on templates. So I'm going to spend a little bit of time on basics. Can you guys see my screen, by the way?
Yes.
Yes.
Okay, because I thought I was talking to myself. So function templates, obviously class templates, and the most important thing, and as some of you may be thinking, why isn't this guy talking about cool stuff like auto and all that stuff? It's because there is an important thing that we need to understand. It's pretty dry, but it's quite important. Template argument deduction, because that is how things work, and that leads us to talk about auto, decal type, which is fairly standard in these modern environment. And then we'll talk about template specialization, versus overloading. So I think of these as the basics, right? All of us sort of have some idea, but we'll dig a little bit deeper. And then more details, sort of an extension to what I'm talking today. And that would be things such as variadic templates. That leads to something new called fold expressions, and miscellaneous things. And then I think of these as techniques. So, for example, mm, these days in modern C++, you don't really need to declare the return type of your templated functions, right? You can use the keyword auto, but obviously I can just let it be like that. So we'll discuss what that means. And I'll do a little bit of TMP. I mean, the focus of the class is not to go beyond, into some crazy areas. TMP basically means template metaprogramming, which is essentially write portions of programs that are completely compiled, right? So the idea is that compiling is going to take a long time, but execution speed is going to be so much more faster. Then I'm going to do a little bit about type traits. Traits essentially refer to genes, a behavior thing. So we need to know a little bit about this so that we can write our own iterators, for example, for any new types that you may build. I introduced this a little bit, uh, and I also need to talk to you guys about this. So all of these are sort of bunched into templates. Like I said, a lot of the advances in modern C++ are coming through templates. All this idea of inheritance is sort of old fashioned, right? We do have it, but there's nothing much going on in that sense. And then obviously part of the course is interested in designing software. So I want to talk to you about how using templates, which is static polymorphism, might be in some cases a replacement for dynamic polymorphism, which is inheritance based, right? So static versus dynamic polymorphism. And then there's a weird thing called CRTP, and the expansion is curiously recurring template pattern. So I'll talk to you guys about that, a little bit about expression templates, and some other a collection of idioms and patterns. And then if time permits, then there's something new and very important in C++20 called concepts, right? And all of this I kind of figured is actually a semester's worth of stuff. So I'm going to try to complete no more than 6 hours, which is a week and a half, maybe 8. All right, but even then we are skimming the surface. So that is kind of what I think I would like to do. And then if time permits, before the midterms, then I would like to get into the standard template library and do a lot of functional stuff. Okay. Now, we still have the basics. So I just want to spend a little bit of time today talking about at least these 4 things and be done. I have a bunch of assignments that are related to command line parameters. And just like in the previous assignment, there is less hand holding from me, more from, you have to kind of figure out how you want to do your thing. And there's also variadic functions. So I'm going to sort of give you a mini programming assignment on this. Think of it as a quiz or a mini program. And then I think we should have an assignment on this so that everybody understands, hey, I built something. So when you go to an interview, you can always talk to people about this, because I think it is quite a big important thing in the industry, because definitely there are more C programmers than C++ programmers. So you're going to have to work with all types of people. All right. So where were we last week? We spoke about pointers to functions, right? And we spoke about how to declare pointers to functions. I'll actually show you some source code because I have it. I think it was put out there uh, in the last weeks, but it's good to kind of just run through that stuff. Many applications of pointers to functions. So let's start with something really basic, right? Sort of like a callback function behavior. If you're building UI or something of that sort, then you are going to be using a lot of pointers to functions. So this is my higher order function called modify. Can everybody see my screen? All right, and this is sort of the idea behind functional programming. Functional programming is sort of dealing with functions, as the name implies, but the idea in functional programming is to treat functions as like any other object. They're first class citizens, right? Just like you can have variables of type, fundamental types. Well, and you can combine them to create higher order types. The idea with functional programming is to create basic functions and then use them to create higher order functions. This is an example of such a thing, right? What I have here is a function that is called modify, and it does some work using a pointer to a function, right? And uh, the basic idea is that by changing the behavior of changing the function that is supplied to modify, essentially you can use modify in a higher order form in an infinite number of ways, right? And this is the basic idea behind the algorithms in the standard library, and we'll get to that. And at that point, we'll talk a lot more about function objects and lambda expressions and so on. So let's just in C we call them callback functions, right? Basically, the modify function is going to be given a pointer to a function, and this modify function using this particular expression is going to call back the function that was given to it. And you can only supply functions in C and C++ to other entities using pointers, right? So here I have a function. What it does is that it uh, is an array. So this is sort of like I was talking to you guys about this. The simplest way. I have an algorithm, right? A patented algorithm that will work. But in the simplest scenario, this is the easiest way. Take the highlighted thing. It's the name. And you got to jump into that part. Because if you're writing a parser for C and C++ code, that's what you would do. Then you would go to the right. So FP array is an array, right? Of what? Well, we have already consumed everything up until the parenthesis, so we need to go left. So right away, you're going to say FP array is an array of pointers, okay? Because that's what the asterisk means. It definitely doesn't mean the multiplication symbol. So this entire thing is consumed and reads as FP array is an array of certain things which are pointers. And what kind? So right away, since I went left earlier, I'm going to go right. And this pair of parentheses indicate the function call operator. So FP array is an array of pointers to functions. And then I dig a little bit deeper and find out that FP array is an array of pointers to functions that take an int. Having consumed to the right, I shift to the left and I find out finally that FP array is an array of elements where each element is of type pointer to function that takes an int and returns an int. And I'm initializing this array, where the size is not specified with two elements. So therefore the size of the array is going to be 2. And both these functions take ints and return ints, right? That is the contract we have. So that is the only way this is going to work. Basically, I have an array and we do stuff with the array by using the subscript operator. And I can indirectly use the function ran100. It doesn't really matter what this ran100 is. Obviously, it returns a random value, right? You give it an integer, it returns some random number. And I'm able to modify this array using another function. And modify is higher order because it can also do many other things. All that it requires is that you change the type of function that you supply and its behavior is going to be different. So here I'm dumping stuff, which is really, where is the dump? It's somewhere here. And dump. Where is dump? Oh, dump is here, which is basically printing each element of the array to the standard output. So that is sort of what I mean by using uh, callback functions, right? And some of you are going to implement animation. Actually, I spent many years doing nothing but animation, and we all need state machines, all right? So I have a simple state machine, for example. So this is a different thing. And each one of these is an animation function, right? Stand, walk, run, jump. And if you wish to draw a picture, you would go, let's say I'm standing, then I do something, the user that is, you go from standing to walk, and from walk, you run or jump, right? So I think the picture that needs to be drawn essentially looks something like this that probably is familiar to all of you. So let me just visualize that for you guys. Um, this is what you would do in your applications. And for the embedded guys, if somebody asks you to design some sort of elevator type system, right, you end up with the same thing. So stand, then walk, and then from walk, maybe you run, and then you jump, right? And then, you can have some actions that take you from this state to this state. And maybe from run, you can't simply end up at stand. That doesn't make any sense. So maybe something like this. This is a state machine. And you probably want to implement this in your game, or it's fairly commonly used even in parsing, for example. If I want to parse C or C++ code, and break them up into individual tokens, we need state machines. So they're fairly commonly used. So I have a structure called state, right? And it contains some data, and it contains where a pointer to the next state, essentially, right? So if I'm standing and you do something, the user that is, then I'm going to be able to go to walk and continue that way. So that is kind of what you see me implement here. Take a moment to kind of look at the stand state. So you pass me the new state I need to go to, and I read some data from input. And then based on the input, I change my state from standing to either walking or jumping. So I'm going to go ahead and change this. So apparently when I'm standing, I can walk or I can jump, right? And it continues this way. So it's not important, but the basic idea is that you have all these states implemented, and then I initialize my state. I'm standing, and I continue this forever until you know, um I guess there is no, how should I put it? In a game, you might have dead kind of thing. Until I die, I'm going to continue essentially dealing with your input. So this is sort of like an infinite loop, and I start at this particular state, which is stand, and based on the input that you provide, which in this case is character A, I'm going to be able to walk. If it's not A, then I jump, and let's go to jump. What do I do here? Well, once I move into jump, I'm going to continue in jump. In a real game, what you would do is you would jump, and if there's nothing that is supplied by the user, you might switch to another state, right? Called the idle state or what have you. So in a jump state, I'm going to continue jumping until you press the E button, in which case I go to stand. And then, the cycle continues sort of like that. So then you press A, I go to walk. And if I'm in walk, well, you press B, I run, which makes sense. Otherwise, anything else makes me jump. And then from the run state, I can only go to the jump state, and it continues this way, right? It's fairly simple and straightforward, in my opinion, to implement basic state machines using this idea of pointers to functions. And you can kind of just quickly program this. You can implement any sort of logic, sort of like this. I don't know. I press A, apparently I end up walking, then I press B, I run, C, I jump, and then I press D, I jump. I don't know how to go to any other state, but you kind of get the idea, right? Pretty simple and straightforward. The only issue if you are working in a game is that this particular state machine must be scripted by you, because your designer, they don't care about any of this. They're going to use a spreadsheet, and they're going to say, I want to go from walk to jump, and it should take this many seconds or frames or whatever. And you're going to take all of that and automatically create this entire business. You would generate these functions, and you would generate the logic, right? Which kind of looks like this. And it gets integrated into the game, and the designer can then go ahead and check how the animation system is working. At least that's kind of what we used to do back in those days. All right, are there any questions? We're going to spend a lot of time talking about functions when I talk about algorithms, function objects, and lambdas. But uh, if somebody knows these things, then I think this is pretty much useful for your current games. Okay, coming back here, the thing that I want everybody to know is command line parameters, because there's some sort of, I was just looking through the internet the other day, and there was some misleading information. I can't remember where, but I felt it was important enough. And so the basic idea is this. Well, all of us know that we can supply input to our program, C and C++ programs, and the input is going to be read through these two parameters, argc, argv, right? Argc is not really required. It simply is there, I think, for legacy purposes, right? And in my opinion, this is kind of how you want to think about argv. So here, I'm calling the program whatever it is. There are 1, 2, 3, command line parameters, right? argc therefore is going to be equivalent to 3. And the reason I said argc is not required is because this is correct, okay? argv by definition, according to the standard, both in C and C++, will have 4 elements, even though we have only 3 command line parameters. And the last element in C++ is going to be containing the null pointer, or in C it's going to contain null, whatever is the meaning of null. And remember, when you think of null and null pointer, don't imagine that they actually are going to be equivalent to 0. You always want to make sure that you disambiguate the meaning of null and null pointer from the integer value 0. It doesn't necessarily have to be equivalent to 0. So when you perform a check of a pointer, the compiler is using whatever bit pattern it wants to represent the null pointer, right? And we don't care. So that is the most important thing. So once we have this picture, clearly I don't need argc to iterate through all of the elements and grab my stuff. So let me explain what your assignment is going to look like. Basically, my problem is this. I have a secret file, right? I work in the spy service. I don't know what Singapore spy service is called, but I'm working there and I have files, right? I don't want the enemy guys to come into my computer and steal the big file. So what I would like to do is break up my file into lots of small pieces and encrypt each one of those. And whenever I want to get back the original file, I run a program which is going to do the opposite of the splitting, which is joining them up, right? And obviously it's going to decrypt each one of these individual files and connect them together. Now, this is what actually happens when you send information through the web, all right? If you use email or whatever and say, hey, I want to send this really big PDF file, TCP/IP is going to break up your big file into smaller pieces. And if you want the fastest transmission, the files are, trivially encrypted. Otherwise, you can choose some complex encryption scheme, and each one of the pieces is going to take its own way to the destination, wherever that might be. And the destination's job using TCP/IP is to collect everything and bring them back together. I think you're going to study that in the computer networking course. So this idea of breaking things up and recombining them somewhere else is fairly common. And I was also researching the web and I noticed that there's a lot of free stuff. 7-zip, for example, the one that I use to zip allows me to break files and join them together. So you are going to build such a feature, obviously without GUI or anything. And what we are going to do is use lots of command line parameters to take care of that. The only thing that you're not going to do is encrypt and decrypt because, I don't know much about encryption and decryption, so I didn't feel that it's fair for you to kind of get into that business. So that is going to be your basic assignment, and I'm going to test it using obviously big files, binary files. I'm going to test it with small files and so on. So you're going to have to do a lot of work in terms of parsing these command line parameters and also do some binary IO stuff. Okay, you see me here using argc. That's the traditional way, but really we don't need argc because we found out that argv is the name of an array, right? Which contains its last element sort of initialized to the null pointer. Okay, multi-dimensional arrays. This is also quite important, important for all kinds of people interested in programming. If you are in the business of games, like I said, when I was doing animations, I used to have 6-7 dimensional arrays, right? Because you're animating a character, there are many bones, and each bone is going to have many frames per animation, and there are many animations, and there are many characters, so it gets really complicated. So I want to help you disambiguate this whole idea of, multi-dimensional arrays, right? So I'm going to ask you to sort of look at my sheet and hopefully interact with me, because if I ask some questions, you can hopefully answer them. So let's start with the most basic stuff. Obviously, if you write an expression such as this, if I randomly pick you guys, any one of you in an interview and say, can you tell me what is mango? What would the answer be? And the guy is going to confuse you. I heard he's going to say arrays and pointers are the same thing. So what do you think mango is? And please, no jokes about mango being a fruit, okay? You're not going to get the job. Best leave the jokes to the interviewer. All right, guys, what is mango?
Mango is an array of 5 ints.
Very good, right? So anybody who has done a bunch of programming courses in C and C++, you are one of the few people in the world who will properly answer this, because most people wouldn't know whether mango is a pointer or an array, because when you apply mango as the operand to the size of operator, the compiler says, hey, mango is an array of 5 elements, but in an ordinary expression somewhere else in your code, mango is essentially going to become a pointer to an array, right? That's why we are able to write code such as this. Okay, so now what's my next favorite fruit? Okay, papaya. I like all these fruits if somebody cuts them up for me, right? It's what a mess cutting these things up. Okay. All right. What would you say papaya is?
Is it okay to say papaya is an array of 20 ints?
Papaya. Okay, no, no.
The array of.
Papaya is an array of 20 ints. Okay.
It's also a 2D array, but.
So maybe a 2D array. Can I say that, Clementon?
Yeah.
Okay.
But like, I think you can traverse it as a 1D array, right? No, you can't.
Okay, maybe a 1D array. Hey, let's have some jokes today, okay? Anybody else? Come on, guys. There's a bunch of you. I need some, we need some joy in this world.
Papaya is an array of in arrays of papaya is an array of 5 in arrays.
Okay. I'm happy that everybody is in a good mood today. Okay. I am too. Because I'm getting tired of bad news. Okay. I'm not going to. I didn't quite get the number 4, my friend. Other than it was funny. Okay. But
you said there's an array of arrays.
Array of arrays. Anybody else? Come on, guys. Only 4?
I think it's array of 4 arrays of 5 ints.
hang on. I gotta catch what you're saying. Array of?
Array of 4 arrays of 5 ints.
Okay. I think number 5 comes closest, guys. What I would actually say is that papaya is an array of 4 elements. So the first thing you need to do is get rid of this whole multi-dimensional thing. Multi-dimensional thing is good when you're drawing pictures like this, chessboards, matrix. All right. And I think of these guys as kind of not really equivalent to this. Instead, it's best to think of papaya in terms of an array of 4 elements, because that's exactly how C and C++ are going to look at them. In fact, since mango is an array of 5 ints, papaya is an array of 4 elements where each element is a mango. Does it make sense to you guys? Although we are mixing up fruit metaphors, but and I'm not sure if I want papaya and mango to be mixed up, but mango is an array of 5 ints. Okay. Papaya is an array of 4 elements where each element of papaya is a mango. Because what is the subscript 0, subscript 1, subscript 2, subscript 3, right? This guy, how big is it?
It's 5 and
5 inch, so 20 bytes. Very good. So you can kind of zoom into this and draw this guy to look like this. 1, 2, 3, 4, 5, where each one of these is 4 bytes, right? So
can I ask if they're allocated sequentially in memory?
of course, that is the D.
No, I meant all 4 of the arrays. Are they lined
Yeah,
up
yeah,
together?
yeah,
So
yeah,
technically,
yeah.
couldn't number 1 be thought of to be true as well?
Sorry.
If they're lined up together in memory,
Yes,
then
they
couldn't
are
we
lined
think
up
of it as
because
just one big
this we are zooming in is apparently 20 bytes, where each element within the 20 bytes is considered to be an int. So therefore there are 5 ints.
But it's meant that all the 20 bytes lined up. So that
Yeah,
way I
yeah.
can go from 0 to 1 without any gaps. And technically,
course.
I think of all these kind of arrays as just one big array.
Well, basically what it is, right? And the point today is to kind of get our heads wrapped around this so that in the future, and by the way, right, I do use them a lot, but it's not like I prepared for today's class. I've been thinking this way for many, many years. I've trained myself. Hey, this is the easiest way, because one of the earliest things I got really confused about when I was learning C was this whole idea of 2-dimensional arrays. And then I realized it's not the proper way to think about arrays of arrays, or multi-dimensional arrays. Instead, think of them as an array where each element of the array is thought of by the compiler as an array. So actually, this set of 5 ints is equivalent to what mango is, isn't it? That's what I meant to say. Papaya is an array of 4 elements where each element is a mango. And if you can actually give this thing a type called mango, an array of 5 ints, then you can actually construct papaya as an array of 4 mangoes. Did I make sense to you guys?
Can say
So
that again.
Yes.
So rather than declaring a variable or an object, let's make mango be this type. Okay. So papaya is an array of 4 elements where each element has to be 5 ints. And that is going to be mango. This would work too. This would work too, because the compiler is deconstructing this into this. But this makes it easier for you to follow what's going on. Why? Because all of us are drilled that when we have an array A of 5 elements, We draw a picture like this, and we say that A, when used in an expression, essentially is the address of this first int, right? And when we write A subscript K, we are actually doing this. Internally, the compiler is further doing this. We don't do this. This is what all we need to do, but the compiler is going to say, hey, A is of this type. So this entire pointer arithmetic actually means size of int, right, times K. But we don't do this. Instead, we think in terms of elements of a certain type. We don't think in terms of raw bytes. All right, so that is the middle part of both C and C++. We don't need to go all the way down to raw bytes. Python stops here. All right, C and C++, well, basically we do this. But obviously Python relies on C and C++ to extrapolate this meaning to this. So why is this quite important? Well, basically, A subscript K is equivalent to this. So if you understand this part, then you know you're well on your way to understanding how papaya works. Right? Whether you write papaya as an array of mangoes or as an array of ints, basically mentally your model is this. 1, 2, 3. Right? Papaya, just like in this picture, right, is going to be the name of this array. But papaya subscript 0, what does that mean? It means this is the name of this entire block of 5 ints. But that is what A is. So what is the type of papaya subscript 0 when used in an expression? It would be the same as A. Am I making any sense here, guys? At least I'm trying to get you guys to disambiguate, because when I was looking at some of the CSD computer graphics stuff where people need to kind of look at 2D stuff, I thought there was some confusion, and that's why I wanted to spend a little bit of time, because you're not serving anybody's purpose by doing crazy stuff, but not doing the stuff that you actually use every day. So papaya subscript 0 means an array of 5 ints. So you can say this is equivalent to this. But when used in an expression, this is the name of an array of 5 ints, and therefore this becomes pointer to an int. So you can take a pointer to an int and say papaya subscript 0 or any other element of the array, right? And I'm therefore going to write it sort of like this. Now, when you say pi subscript, sorry, did you? Oh, sorry, the paper, right? Yeah. So when you say pi subscript 2, basically what you're doing is pi is essentially pointing to the first element of the array called papaya subscript 0. So anywhere you have the name of an array, you can use it in a pointer expression, right? This is the fundamental rule, that connects arrays and pointers. So A is the name of an array, but if you have another pointer variable that contains the address that A has, then that is why we are able to kind of use either pointers or subscripts. And in fact, the compiler is going to decompose this into this. We call this syntactic sugarcoating, right? So this is really what it is. Well, applying that same logic here, papaya is subscript 0 being the name of an array. If I write this expression, what I'm really doing is I am saying this, right? Because I'm saying go to the first element of this array. Well, this element is made up of 5 ints, and I want that third element within that particular array. So therefore, the type of this expression is going to be an int. And finally, that leads to this final question. What is the type of papaya when used in an expression? Right? Guys?
Can you repeat the question?
So papaya is an array of 4 elements, where each element is an array of 5 ends. So papaya subscript 0, subscript j refers to any one of these elements and is nothing but an array of 5 ends. And when a name of an array is used in an expression, the name decays into a pointer to the first element. So if mentally we are thinking of this as the name of this array of 5 ends, then when used in an expression, this will decay into a pointer to the of these first element of these arrays of 5 ends. So I'm now asking you to zoom out and forget about the trees now. Take a moment to kind of look at the big picture, the forest. Your forest is made up of 4 elements. Don't worry about the individual trees within each one of these, within the particular element of the forest. So I'm asking you, what is the result of the evaluation of papaya? What does that mean?
Wouldn't it give you the first pointer to the first array?
It
If
gives
plugs it
you,
in and then it decays to a pointer, it will be the first array of the 4 arrays.
so how would you declare it? I mean, what is the type of the pointer that you need
Oh,
to
it will
assign
be
papaya to?
papaya would be a pointer to an array of ints. So 2 pointers. Yeah, like that, right? Yeah.
Anybody agree? Disagree?
Is it just an in pointer?
I think it's just an int
I think it's
pointer.
just one int actually, yeah.
So int pointer, pointer.
No,
Two
it's
choices,
it's the first one.
just like your attendance, either this or that. Neither is the answer.
No, it's the first one.
Int pointer.
No, because hang on. I'll try again. Int pointer should not be sort of in the picture. Okay, let's draw again what it is that we have. Ah, 4 elements. Each element is made up of, I hope you can see my particular picture. Each element is made up of an array of 5 ends. Can you see? I've broken it up, right? 5 ends, 5 ends, 5 ends, 5 ends. And this is papaya subscript 0, papaya subscript 1, papaya subscript 2, and papaya subscript 3. Papaya, papaya, yeah, 3. Is this clear to everybody, this picture?
Yes.
Given the
Yes.
given the definition papaya 4, 5. Okay. Clearly, this isn't it equivalent to one of the earlier definitions we saw? I mean, obviously, A is somewhere else in memory. Papaya subscript 0 means another location in memory. But in terms of meaning, would you not agree that this and this are the same?
And that's what we said. Papaya is
Okay, hang on.
this array.
Okay. No, that's not what I got. But I want to get past that sort of where the answer was an int pointer. So that's what I was trying to explain. So if this subscript 0 is equivalent to A, then just like when A is used in an expression, when papaya subscript 0 is used in an expression, it becomes a pointer to these guys, right? To the first element of this array of 5 ints. Papaya. So what I was trying to say, folks, is that if you take papaya itself, how can I then use an int pointer to initialize papaya if papaya subscript 0 is already a pointer to an int?
So it'll be a pointer pointers?
Okay, so
It'd be a pointer to an array of 5 ints.
okay, that's good. So there's one answer, and what was the other one, my friend? What did you say?
Pointer to an array of 5 ints.
Pointer to an array of 5 ints. Like this? Our friend is correct. The only issue is the compiler is going to say, because think about it, guys, papaya is an array of 4 elements where each element is of type X. Papaya, therefore, in an expression, the name of the array must evaluate to be of type pointer to X. What is X? An array of 5 ints. So therefore, papaya will be a pointer to an array of 5 ints. The only thing left to do is to actually express that so that your C++ compilers understand what you're saying. So this is my first attempt based on what our friend just described. So the compiler is going to come along and use that right left rule that I just described. This is the name. Then what is it? Where does it go? Left or right?
But when you pass it into a function, you need to pass it as an int pointer
We'll,
pointer.
we'll get there. We'll get there. But I was trying to parse this out. PA5, this is the name. Where do you go next based on the description that I provided you?
You move to the right.
Very good. PA5I is an array of 5. Well, there's nothing more to consume, so it's going to go left. And each element is of type pointer to an int. That's not what you want. You want PA5I to be a pointer to an array of 5 ints. Because if you want this guy to point here and you say PA5I plus plus, it should skip past 20 bytes and get here. And you say, well, increment it one more time, it should get here and get here. But if each element is an array of int pointers, when you increment that, you're only going to go by 8 bytes. Which kind of in this particular picture is meaningless because each element of the array is 20 bytes. And within that element, each of 20 bytes, there are 5 elements, each element of size 4 bytes. So advancing by 8 bytes doesn't help anybody. So the thing to do is to be clear in when you talk to your compiler. Since this is the default precedence rules that are being used by the parser, even though there's no expressions here, they follow the rules that are specified in the precedence chart. We need to break that built-in rule. And instead, we want to say PA5I is a pointer to an array of 5 ints. So we need to put a pair of parentheses so that the compiler, when it comes here and goes right, there's nothing more to read. Instead, we want it to go left and we want it to say PA5I is a pointer. And then it's going to go right. Pointer to an array of 5 ints. So then PA5I is pointing here, right? Then how do I access the individual elements? Well, there are a couple of ways you can do that. The first one is quite simple. Apply the dereference operator. So this, instead of being a pointer to an array, this entire thing will become the name of an array. And then pick which one of the 5 elements you want to go to, right? Does this make sense? Or the other way to think about it is that this unpronounceable thing is an array, is the name of an array of 5 ends. The pronounceable thing, where we drop out the unpronounceable asterisk, is therefore a pointer to an array of 5 ends. And since this is a pointer to an array, we want to get the name of the array. So we apply the dereference operator. And when we apply this parenthesis, this entire unpronounceable thing is going to become the name of an array. And then I can access the individual elements. Now, PA5I plus 1. Plus 1 means we are adding 20 bytes. Apply the dereference. Well, okay. So then it allows you to access the element of this. This can be simplified and rewritten like this. Excuse me. Am I making any sense here? Nobody's saying anything at all.
But when you pass it
Okay,
okay,
you
when
wanna
you pass papaya into a function, then when you traverse it, it needs to decay into a pointer to and a pointer to a pointer.
Yeah, we can take a moment to look at that and write. Hey, why don't I give it a cute name, papaya? Can you guys see my screen? Is it big enough?
Yeah.
Okay. First of all, I'll do what I was suggesting. Okay. And just to kind of, give everybody the sense that papaya is really an array of 4 mangoes, where mango is an array of is the new name for an array of 5 ends. Then the only question is, hey, is the compiler understanding what it is that I'm trying to say? So G So papaya apparently is an array of 4 mangoes, where each mango is an array of 5 ends. So if some of you are unable to understand me because I'm not doing a good job, then I'm hoping that this will make sense to you, because we are deconstructing, right? The big thing and breaking it up. Sorry. Okay. Does somebody want to say something? Okay. My next favorite fruit is kiwi. Okay. So let's go kiwi. Fine. Are papaya and kiwi exactly the same? Yes, they are. Obviously, they're first class citizens, so you cannot assign kiwi to papaya or papaya to kiwi, but internally, both are exactly of the same type, because papaya is being constructed using mango, while kiwi is simply saying, hey, I'm an array of 4 elements where each element is of type pointed to, where each element is an array of 5 ends, excuse me. All right, let's write a little piece of code. Maybe Let's write foo, or maybe, fruit. And we wish to pass papaya, kiwi to this particular function. The way we were taught to do this at the very conclusion of HLP1, I don't know if we ever talked about this in HLP2, I can't recall, was like this. The idea was that, hey, your compiler, and I'll explain to you how most people kind of provide information about that. This is papaya. It is 1, 2, 3 row, 4 rows, 1, 2, 3, 4, 5 columns. And you want to pass this to a function. Well, basically, the function needs to know the number of columns so that it can perform some arithmetic and get to each one of these subsequent rows. If you don't provide this number 5 hard coded in this particular function as I did, then it's not going to work. Where am I? Here. All right, so this is, notice, hard coded. This fruit thing will only work for arrays of where the number of columns is 5. And this rows here is supposed to be in both cases 4. Obviously, you can have grape, which contains 8 elements, where each element is exactly the same type as papaya and kiwi. So when we call fruit with grape, we are going to supply the argument 8 as a substitute for the parameter rows. So when we call this particular function, what we would like to do is I would just like to initialize 1, 2, 3, 4 like this, 5, just so that we can access the actual element. 11, 21, 31, 41, 51, and then 22, no, just one more, and then we are done. 22, 32, 42, 52, 62. Something like this, right? The rest are going to be zeros. And I want to call fruit papaya and say, let's get the value of the element located at row 1, column 2. So we should get back 31, right? So row is 1 and column is 2. Okay. And what we are doing here is syntactic sugarcoating, and the compiler will print 0, 1, 2, 31. Okay. Poor choice of parameter names, but I gotta live with that. Okay, 31. Okay, so I'm gonna write fruit 2, right? Except here, we're gonna say what we mean. No syntactic sugarcoating. I'm gonna tell the compiler, hey compiler, I'm sending you a pointer, right? Because that's what we normally tend to do with one-dimensional arrays. We send the address of the first element, and we say, I'm sending you a pointer to an int. So here, it's going to look like this. X is an array of X is a pointer to an array of 5 ints, and can use it with Kiwi now and simply say I'm going to pass Kiwi and supply exactly the same parameters. And Kiwi will also be initialized with exactly the same stuff, right? So it should print 31.2. But how do I dereference? Well, X is a pointer. So one way to think of it is you are doing this. X is a pointer. So you apply the dereference operator. So this is no longer a pointer to an array, but this becomes the name of an array. And I'm able to now access 3 and 1 like this. So I simply say return. Does this make sense, guys? Actually, I'm a little annoyed that I made this mistake. It should be X. Precedence chart plus. I'm trying to make sure that the dereference operator is first, dereference, and then there's the subscript. So the subscript is higher. So once we confirm that, so X is a pointer to the first. So X is a pointer to this entire thing. I want to get here. How am I going to do that? Well, I add to X, the size of each element. So that takes me here. Now I apply the dereference operator. So that gives me this array. Within this array, I want to get to this element. So instead of 1, I go with R, and then I do subscript C. Does this make sense? By the way, subscript has a higher precedence, so I'm going to do this. Guys?
Yep.
Now, obviously, we can simplify this like this. Because this entire thing can be rewritten like this. So this goes away. And this entire thing becomes a pointer to this particular array, or the name of an array. And then I'm accessing a particular element within that array. So either is going to work. Let's compile. So that's really all I wanted to say about this particular thing. And if we add +1, if I do what I'm doing, I should get 42, right? Just to show you. Because X is no longer pointing to this array. Because of this, it's pointing to this array. Since R is 1, we are skipping past this entire set of 20 bytes, and now it becomes a pointer to this array. And the subscript operator means we are dereferencing that pointer. So instead of a pointer to an array, I have the array, sort of like the name of an array. And then I want to access a particular element within that array. And I believe we should get back 42.
Sorry, Professor. Should it be fruit 2?
Sorry?
Should it be fruit 2? Like when you call at line 17?
No, this is correct.
Oh, okay.
Hang on. What did you say? Because there was some static.
Fruit 2. Like, should you call for fruit 2?
So you want me to call fruit with which parameters?
No, Prof, I think she's saying call fruit2 instead of fruit. The function on line 9.
Oh, thank you. Okay. It's like a magician, right? Sleight of hand. Hey, it's all working. Let's move on. Okay, thank you. Uh, there. Happy? All right. Now, obviously, now you kind of have a sense, right, of what's going on. This is going to be where I'm going to now end up talking to you guys about one last thing, because we can't stop here, right? Because you're not going to stop here in the real world. So we took care of mangoes, right? We took care of papayas. We took care of kiwis. I think I'll go with pears now. What is the meaning? So let me write everything down. Mango was for us this. Papaya was this. So now you should be able to kind of think about pears logically by extrapolating. Would everybody agree that a pair is the name of an array of 3 elements where each element is a papaya? I mean, do systems thinking, right? Abstract away all of the low level stuff. Because the low level stuff, you understood. You understood that mango is this. 1, 2, 3, 4, 5, where each element is 4 bytes, 4 bytes, 4 bytes. So it's an int. Then you understood this to be like this. I have an array of 4 elements where each element is like this. Right? Then this guy is simply going to be an array of 3 elements where each element is this. That I find to be sort of like my how I think about these things, right? And I should tell you, I do get confused, all right, when I'm programming. But I come back and analyze all of this with something that makes sense to me. And then I go back and solve the problem that I have. So pair is the name of this array. When used in an expression, pair becomes a pointer to the first element of this array. So pair plus 1 is a pointer to the second element. Pair plus 2, as you can imagine, is a pointer to the third element, right? Now, how do I get to each one of these papayas? Well, we can do something like this. And in each case, it's nothing but this. Plus 0, 1 or 2. That's really all there is. So in place of pair, if we have some arbitrary pointer that has been declared and initialized properly, then all of this magic is still going to happen. Now, how do you access a particular element of papaya? Well, pair subscript 0 gives me this element. How did I access a particular element of papaya? Well, I decide which one of the 4 okay, pair gives me this. See, I'm getting confused with my picture. 1, 0, 1, 2, 3. So pair subscript 0 gives me this entire thing. I want to access this particular element. Within this element, I want to access one of these 5. So let's go with 3. Does it make sense? How we are traversing from this to this, and then we are saying, OK, this gives me this. Within this, I have 4 choices, 4 elements I wish to access. I'm interested in this, but this itself is made up of 5 elements, each of type int, and so therefore I can each subscript is essentially giving me that. Now, in terms of pointer arithmetic, how would it work? Let's do it by hand and then use a computer. So integer pair has been defined like this. Let's suppose we wish to declare a pointer, right? Let's keep it simple and call this pointer P. Based on what we know, this guy is going to be of type P is a pointer to an array of 4 elements where each element is further subdivided into 5 ends. So this P is pointing to this location. Can you guys see that? So we got P. Now we want to do exactly what we suggested here. We want to access, so we go like this. This guy is made up of 5 elements, so I wish to access this element, and this has 5 ends, so I would like to access the 4th int. So I would like to write something equivalent to this using P, right? Now, clearly, P is a pointer to papaya. So P subscript 2 is essentially going to give me this because P is a pointer to this thing. Applying the dereference operator, maybe I should do this. Applying the dereference operator gives me this entire thing. Then that particular thing allows me to express subscript 2, right? Which allows me to, because, okay, P is of type pointer to an array of 4 elements where each element is an array of 5. So I wish to access the 3rd element of this particular array that P is a pointer to. So I apply the dereference operator. So then I get the name, so to speak, of this array. Well, when I apply the subscript operator, then with given a name of an array, I get access to this. This itself is the name of an array of 5 ends. So this entire thing, subscript 3, is going to do the trick. Does this make sense?
Yep, makes sense.
All right. I'll let you guys sort of just take a moment to think about this. Maybe if you want, you should take a piece of paper yourself and see if there are any questions. Okay, let's code it up. So we'll get rid of the gray part. So we took care of these guys. So now let me create so the first element, okay, is going to be initialized like this. So this is essentially going to be subscript 0. Add 33, 33, 53, 63, 73. Okay. So this entire thing, 1, 2, 3, 4, is basically initializing the very first element of pair, right? So let me take the time to initialize the second element of the array because we were looking for that. So I'll just go like this. All right. I don't care about the last element. All of the elements, 20 remaining elements are going to be initialized to 0. Okay, so we got that. Now, I'm going to initialize P, which we chose as our name of our pointer, to be initialized to pair plus 1. Is everybody clear about this thing? One way to think of this, sometimes which I do mentally, is this entire unpronounceable thing is the name of an array of 4 elements where each element is an array of 5 ints. So therefore, P is a pointer to such an array. Okay, which is exactly what pair plus 1 is. Pair subscript 1 is an array of 4 elements where each element is an array of 5. I want a pointer to that. Well, all I need to do is get rid of the dereference and I end up with that pointer. So now we would like to print pair subscript 1, subscript 2, subscript 3, right? And subscript 1, within that I want 0, 1, 2. Within that I want 0, 1, 2, 3. So we really should be getting 520. Does everybody agree? When you look at my,
Yep.
okay. So P is a pointer. So P is going to become, upon the dereference, P is no longer going to be a pointer to an array. This entire thing is going to be the name of that array. Which array? An array of 4 elements where each element is an array of 5. Within this array of 4 elements, I wish to access the third element. Well, that gives me in turn an array of 5 ints in which I want to access the fourth element. No, like that. And 520. Does that make sense, guys? Once you kind of get the hang of it, right? To be honest, the last time I looked at it was a long time back, all right? Not something I look at every day, but I think if you train yourself to think not in terms of multidimensional, simply array of arrays, and if you know the basic rule of array, one-dimensional arrays, that is, then you're in good shape. Any further questions? Let's write a function called one final function called fruit3, and this guy is going to be like this. And these are good candidates for templating, right? Using non-template parameters, because this guy will only work for an array, where the number of elements is 5 ints. So here, frame, I wish to access a particular frame. Within that frame, I wish to access a particular row. Within that, I wish to access a particular column. I think in terms of frames because of, again, like I said, I used to do a bunch of animation. And now when I call pair like this, or fruit 3, and I give it pair plus 1 followed by 2, 3, we should be able to get exactly the same result of 520, and nothing much is going to change. There's no difference between P and X. If you figured this out here, then you should be able to figure out, with the only caveat that, for example, if I do this, then X is 20 inches behind P, right? And so we need to kind of make it be X subscript 1 subscript, I'm not using frames, so subscript F, subscript R, subscript C.
Professor, your line 29 only has 3 parameters.
Oh yeah, thank you.
Yeah.
520. That's really all there is. So this kind of does two things. It allows you to deconstruct and think about higher level arrays. And I'm pretty sure many of you, whatever field you go into, data science is nothing but a whole bunch of tabular information, right? If you noticed in Excel, which is a table, you can have sheets. And so each one of those sheets is adding a frame, right? And if somebody gives you that whole thing, then you essentially are looking at multi-dimensional information. Okay, the other thing is, given an array of 20, 60 ints, I think this was what Clementine might have been referring to earlier. If you have an array of 60 elements, (20, 60), right? Why 60? Well, basically because there are 60 ints here. 20 times 3, 60 ints. If somebody gave you memory, okay, a block of 60 ints, will you be able to kind of figure out how to take this linear array and map it to this meaning?
Yeah, it's similar to mapping a grid in a 1D array, a 2D grid. You have to just offset the modulus of each
Okay,
row,
so
like column and all that.
okay, so what would I need to do to, supposing we initialized P60, okay? Or I wish to initialize, so I would like to write a loop. So I'll make it be simple, because this is the last thing I want to talk about. 3 plus plus F, right? So I'm going through each frame for, I'll use row. For each element of this array, which is of 5 elements. How do you go ahead and initialize P60 to have exactly the same contents as your pair? That was my question. Think about it, guys. This is a good exercise. If there are any questions, obviously now is a great time to ask for help. Almost everybody else in the school, TAs, whatever, they're all going to get confused. So you have to come to me. So why don't we just figure it out now?
You can solve the problem with like just 2D first, which is the same as like you,
Oh,
the dog's barking.
you basically
You add the total number of rows, modulus.
You want to go like this?
You have to use the modulus to add. How do I explain it? It's easier to write the code for it.
You want to do something like this?
No, I was thinking more. You just add the offset based off the total number of rows and modulus by the current row. That will give you that. Then
What
you
is the expression?
size of
No,
it.
no, you're right, but
You mean the
what do
actual
you
code, right?
what do you think is the expression? No need to code, just think. So take that picture that I drew. Which one do you guys recall? This one. Yeah, let me come back to this. It looks a little bit dirty, but this is the right picture we need. Actually, it's upside down. Hang on. I can make head or tails of this picture. Well, it's
Like
got to be
do
this
just
one.
F plus number,
Oh,
total
pair
number.
is 3 elements. Here, each element of pair is this. Each element of this is this. So you know how to go from here to there. So do you know how to go from each one of the how to traverse these 20 elements? If you know how to traverse these 20 elements, then these guys can be thought of as a frame. I'm going to draw a picture that kind of maybe brings that idea across. Can you see that? This is frame 0, frame 1, frame 2. Frame 0 is associated with this guy. Frame 1 is associated with this guy. So to get to frame 1, I need to pass through frame 0. To get to this guy and set these values, I obviously need to know how to go from F0 to F1 and end up at the start of F2. So the basic idea from this particular picture is, if do I know within this particular element how to access the entire set of 20 elements as a linear array, which is what you see here. But so this is nothing but papaya subscript I subscript j, right? Which allows me to access this. But the I and the j, how would they map to a particular location? So this would look like this. This is going to be I times which particular element. I'll label that as R. J refers to which element within this. So do you guys get the arithmetic? Hang on. It should be 5, not R. And I should be R. Can you guys understand this? R subscript 5 plus C allows me to access this particular element located at R. Within that R, I have a particular element C between 0 and 5. So this is the arithmetic. Let's do it again. I have 1, 2, 3, 4. 1, 2, 3, 4, 5. Each one of these is 20 bytes, 20 bytes, 20 bytes, 20 bytes, 20 bytes. But each one of them internally are thought of by C as being made up of 4 bytes, 4 bytes, 4 bytes, and another 4 byte ints. So there are 5 of them, right? And this is entirely called papaya. So when you write the expression papaya subscript R subscript C, R is going to be one of these guys. 1, 2, 3, 4. So I don't need this guy. It's going to be one of these guys. Within this guy, there is another array of 5 ints. So C is going to be between 0 and 4. Now, if we have an array, a block of 80 bytes, right? Not papaya at all, but something else. How would you access this block of 80 bytes as though it was papaya? Essentially was my question. So my answer to that was papaya subscript R. Papaya plus R, right? So R is, let's say, 2. So from this address, imagine that address to be 1000. You're jumping past how many ints? Well, you're jumping past 40 bytes. In other words, you're skipping past this entire array of 5 ints and another array of 5 ints. So this address is going to be papaya plus r times the size of each one of these arrays, and that would be 5. Now within this, once I position my pointer to essentially be at this particular location of 20 bytes, block of 20 bytes, I want to access one of these elements. Well, all I need to do is treat this as a 1D array and simply use an integer offset. And that offset would be given by C. So if the name of this particular pointer pointing to this block of 80 bytes is P, then the arithmetic that we would use is P plus R times 5 plus C, right? To access the particular element we wish to um, access in this 1D block, thinking of it as though it is a 2D block. Now, if we know how to get to this, there are 3 papayas, right? There is 1, there is 2, there is 3. So if you are accessing for the first one, then this arithmetic will do. But if you're accessing for this one, then you got to skip past all of these bytes.
Which
How
we
many
know.
are there?
2 times 3.
So that would be
5. I think.
3
3 and papaya. Each of the 3
times
is 2.
5
Wait, why 5?
times f, where f is 0, 1, or 2. So if f is 0, this entire thing is 0, so I'm here. If f is 1, then I skip past these many 3 times 5 times 1. No, actually it's 4. Excuse me. 4 times 5 times f. So I would skip past 20 bytes and 20 ints. Once I get here, I can access any one of these 20 ints using this arithmetic. Now, if I want to get here, then f would be 2, and multiplying with 2 would take me past this first, past this second, and position me here. And then I end up with this picture again. So basically then it would look like this. 3, no, 4 times 5 times f plus
row would be 4.
r
R
times 5 plus c.
which can be written as like number of columns times number of rows times f plus number of rows times r plus c.
Maybe I should write it like this to be more synchronous. So this takes me to each one of the different papayas. Within each papaya, I can access a particular mango. Within the mango, takes me to a particular int within that mango. Make sense, guys? So now, how do I get 520? Well, P 60 subscript 1 times 4 times 5, because we want to access the second frame when f is 0. Within that frame, row is 2. Within that particular row, I want to access the 4th element. We should get exactly the same as we were getting earlier. There. So for 5D, you have to kind of sit there and figure these things out. And try to do abstractions. You know all there is to know about 1D array, then you work your way up and say, I know what there is to know about an array of arrays. Then 3D arrays essentially are nothing but an array of arrays. I hope I made sense. So that takes me to quickly show you this is just sort of saying that how do we create a declaration? So a declaration is made up of um certain technical terms, not important, but we call it the base type. All of the, so for example, if you have int x, well, the base type is going to be int, the declarator is going to be the name. If you're declaring a pointer to an int asterisk x, int is going to be the base type. The declarator will contain the asterisk and the name x. Okay, so I took the grammar down and made this table. So declarator, you can have 0 or more pointers. Exactly one, you're going to have a name when you're making a declaration. And you can have 0 or 1 initializer. Not very sort of useful for this particular class, but I just kind of giving you the whole story. And when you think of a type specifier, normally when I teach HLP1, I do use these terms. So a type specifier is obviously your char and short and int and so on. Storage class, register is extinct now in C++17. Auto has been repurposed. This is obviously for HLP1. Extern, static, and type def. Type def is weird because it's meant to create new names. So the only two meaningful ones left are extern and static. If you're thinking of both C and C++, register obviously makes no sense in C++, but in C, it still serves a purpose of potentially storing things that you use commonly in a register, right? And then we have type qualifiers, and the two that we are familiar with are const and volatile. So basically, if you want to create a declarator or a declaration, I should say, you're going to have exactly one declarator. And we saw that declarator being just a name and any other decoration that might come along, such as an array, a pointer stuff. In C++, the reference. And then you can have more declarators, but we don't need to have more than one. So that's why I go 0 or more. And then we need the comma to separate the declarators. And then we stop everything with the semicolon. So we got to have exactly one. And the base type itself is going to be specified by any combination of type specifier, storage class, type qualifier in any order, right? That's why I make use of that to write not const int like everybody does, but you go int const so that I can read from right to left. And why do I read from right to left? Well, it makes, as I'll show you, makes more sense. There's certain things you can do both in C and C++. You can have a function return a function. And so these types of things will never arise. You can't have a function return an array. Arrays can't have functions. Arrays can have arrays, as we just found out, but not functions. So what's allowed is grape is an array. No, grape is a function that takes a pointer. No, hang on. Am I reading this properly? Grape is a function that takes nothing and returns a pointer to a function that takes nothing and returns an end. For a moment there, I got confused because I did not follow my right left rule. Grape, go right, is a function. Does it take anything? Nothing. So grape is a function that takes nothing. You go left. Grape is a function that takes nothing. And obviously, The rest must be a return thing. So grape is a function that takes nothing and returns a pointer. Well, I consumed all of this, so I go right. Well, what does it return? This means a function, and a function that takes nothing and returns an int. So grape returns a pointer to a function. Pair is a little bit different. Pair is a function that takes nothing and returns a pointer to an array of ints, right? Mango is an array of elements. I don't know of what kind until I go left. Mango is an array of elements where each element is of type pointer to a function that takes nothing and returns an int. Kiwi, as we just realized, is an array of so many elements where each element is an array of more elements. Obviously, this number must be specified, right? Because otherwise it's not going to work. And again, for some reason, I'm running out of time, but this is the rule. And some of you might actually be interested in following this algorithm, which is given in a form of a picture, right? So you follow the arrows as we parse. So it's like a state machine that you see here. And that particular state machine can be used to evaluate next. Next, is there anything to the right? Nothing. Next is a pointer. Well, we consume the innermost parenthesis, so I go right. Next is a pointer to a function that takes nothing and returns a pointer to a read-only pointer to a char. Does it make sense to you guys? And this is actually a function from Linux. So next is a pointer to a function that takes nothing but returns a pointer to a read-only pointer to char. C is an array of 10 elements where each element is a pointer. So we consume this thing, so go right. C is an array of 10 elements where each element is a pointer to a function that takes a double pointer to an int and returns a pointer to a char. I hope I made it easy for you guys. So I'm going to leave the thing for you guys to figure out. How much time do we have left?
We have until 11.
So how much time do I have?
13 minutes.
Okay. Because some people in the 2100, they said they're not too happy when I go from 3:30 to 5:30. They tell me that the class ends at 5:10. Is that true? Because
No.
I asked the registrar's office and they said SIT has this weird system of putting everything only in blocks of hours. They can't go below, but I was told I should really stop at 10 minutes too. That is the time people have to go to some other class. So I'll cover the rest next class. But I'll be around if people need to leave, that's fine, but I'm around in the next 10 minutes to see if was there any help anybody needs to understand the array part. And the declarations part. So can you guys do one thing in a few minutes? So write down, right? The grape declaration because we won't be able to look at it. So write it down. Grape. right? And I'll show you how to parse something using that particular picture. Did you guys write it down? Grape is a function that returns a pointer to a function that takes nothing and returns an int. Okay. So first, as I said, we go to the very first identifier. In fact, we go, as we say here, to the leftmost identifier. In our particular declaration, grape is the one, right? So then we look at the next token to the right. And we don't look at just characters. We are going to be greedy. And we're going to go past individual characters to get the entire token's meaning. So when you go to the right of grape, the token that you get is the 2 parentheses. So every time you read something, cancel it out and write down in English, grape is a. And then when you go into the next token to the right, if it is a square bracket, no, it is not. If it is an opening parenthesis, okay, we have an opening parenthesis. So then you come here. How to read? Read up to closing parenthesis. I'm looking at the rightmost column. Read up to closing parenthesis saying function returning. So grape is function, right? Returning. Now, hang on. Actually, let me start again. Go to leftmost identifier, which is grape. Then look to next token to right. If it is a square bracket, which is not. Number 3, if it is an opening parenthesis, yes, it is. If token to left is an opening parenthesis, which it is. Let me shine my pointer here. It is. If token to left is an opening parenthesis, which it is, then keep this is opening parenthesis, grouping together part of the declaration we have already dealt with. Read up to the balancing parenthesis, starting again at step 2. So there's nothing to read. Grape is a function taking nothing, and then what does it say? We go to start again at step 2. So then I have read everything until this ending point. Then I go to step 2. Look at token. Next token to right. It's a square bracket, or if it's, hang on guys. Or if it's an opening parenthesis, if token to left is opening. So I come here. And if I come here, keep reading tokens to right. So say I didn't for each pair, say array is, this is opening parenthesis, grouping together part of the declaration we have already dealt with. Read up to the balancing parenthesis. Okay, I read up until the balancing parenthesis. Start again at step 2. So I go to step 2, look at next token to right. If it is a square bracket, well, I've consumed everything. Is it an opening parenthesis? No. Is it tokens that remain form the basic form of declaration? Read off tokens that remain, well, there's nothing to remain. So where do I go? So go to, where do I go to right? Oh, go to left. See, I'm getting my right and left mixed up. I'm really sorry. Go to leftmost identifier. Hang on. Okay, you know what, guys? Very quickly, next class, I'll figure out the algorithm is burnt into my brain that I need to kind of figure out how my brain is connected to this particular algorithm. Uh, so if somebody needs to go, please go to your class. I'm just thinking aloud here. Start at leftmost algorithm and start at leftmost identifier, which is great, right? So possible size, no. Possible, so I continue. Possible parameters, so I continue. Look at next token to right. If it's a square bracket, no. If it is an opening parenthesis, then what do I do? Then if it is an opening parenthesis, read up to closing parentheses, saying function returning. So grape is function returning. And then if token to left is an opening parenthesis, no. If token to left is any of const, volatile, or pointer, which it is. So I've consumed grape, I've consumed the opening and closing parenthesis to right, so I go left, and then I see this thing, right? And that thing is this thing. And so we say grape is a function returning. For pointer, we say pointer to. Grape is a function returning a pointer to start again at step 4. So go again to step 4. If token to left is an opening parenthesis, which it is now, then what do we do? Stuff already dealt with, which it is, because I've read the asterisk, the grape, the opening closing parenthesis. So this stuff has already been dealt with. And so read up to the balancing parenthesis and start again at step 2. So grape is a function, takes nothing and returns a pointer to, and then it says go to step 2. Look at next token to right. If it's a square bracket, no, it is not a square bracket. Is it an opening parenthesis? Yes, it is. So then I read up to closing parenthesis saying grape is a function that is returning a pointer to a function that is read up to closing parenthesis that is returning, and then if the opening parenthesis, then if token to left is an opening parenthesis, no, there's no opening parenthesis. Then if token to left is any of const, volatile, no, it is not. Then tokens that remain form the basic type of declaration. Read off tokens that remain, example, int. So the whole thing reads as grape is a function returning a pointer to a function returning an int. Complicated, but that is what it is. Did I make sense to anybody who's still around? So that's kind of what we need, this sort of painstaking detail. And obviously, we're talking about a parser for a major language, so it's not easy. But mentally, I have a idea of going left, right, left, right, alternating. And there is a term for this, boustrophonically, alternating right, left, and it works for me, right? So there's one last thing. Next is so I'm going to try with next. The rest of you, if you need to go ahead. I'll repeat this next time, but I just want to prepare myself for next time. Okay, so I'm looking at this. Then I start with the identifier. So let's cancel all this stuff out. So I start with identifier, which is next. Look at next token to right, which is actually a closing parenthesis. If token to left is opening parenthesis, it is not. If token, if it is an opening parenthesis, no, it is not. If it is not an opening parenthesis, then read up to closing parenthesis. So next is, so hang on, next is the leftmost identifier. Look at next token to right. And it's not a square bracket, it's not an opening parenthesis. If token to left is an opening parenthesis, which it is not, is it const volatile? Well, it is this. So then keep reading tokens to left until it is not one of these. For const, for this say pointer 2. So next is a pointer 2. And then I'm crossing out next, I'm crossing out the asterisks. So I start at step 4. If token to left is an opening parenthesis, which it is, then this is stuff I've already dealt with. Then we have start again at step 2. So what do I have? Next is a pointer 2. And then I start here, look at next token to right, square bracket, no opening parenthesis. So if it is an opening parenthesis, read up to closing parenthesis, which and say next is pointer to function returning. Okay, then what do I do? Once you read this, then if token to left is an opening parenthesis, which it is not, then if token to left is any one of these, which it is, because I have the pointer asterisk symbol, keep reading tokens to left until it is not one of these. Well, I go left, and first of all, for the first dereference, I say next is a pointer to a function returning a pointer to. For const, I say read only. So returning a pointer to read only. Then I get another pointer. So next is a pointer to a function returning a pointer to a read only pointer to. Right, and I keep reading tokens to left until it's not one of these three. Well, I get to char, it's not one of these three. And then I go to 6. And 6 says the remaining stuff is going to form the basic type of declaration. And so you simply read off the char. And at the end, I have next is a pointer to a function that takes nothing. And that nothing part is kind of something that we need to do here. But in our case, there's nothing to read. And so next is a pointer to a function that that returns a pointer to a function that returns a pointer to a read-only pointer to a char. All right. So the algorithm works. It took me a couple of minutes to kind of get inside it, but a couple of times and it makes sense. I got confused going left, right, but that is what it is. Are there any questions, guys? Okay, all right. I'll see you guys on Thursday.
Professor, can I ask when the next assignment will be released?
So I'm gonna have to switch. So I'm gonna give the very variadic stuff on Thursday and look for maybe the command line today or tomorrow morning. Hello?
Yeah, so the quiz will be the assignment will be released on Thursday.
Yeah, because at this point, the online grading system is not working with the binary files because it thinks binary files are executables. So they are being kicked out. So I'm trying to figure out a way to get it to work. So it's a technical problem. I can give you guys the assignment, but if somebody finishes it and wants to look at it online, I want to make sure everything is prepared. So I think I can get it done. I know how to go about fixing it.
Okay.
All right.
Thank you.
No problem. Okay, guys. All right. I'll see you.